All right, good morning. And today we are going to continue. We got a little bit more review. So we took that first test, a little bit more review, and then we'll get into our pre-calc in just a little bit. So today we are going to be reviewing a little bit of distance and midpoint formula, or just how to find the distance and how to find the midpoint between 2 points. So if we look here, there's a couple ways we can think about this. The first option, if we have our 2 points on a graph here, and maybe you just are given 2 points like in example 2, but you could graph those if you wanted to. Now, if we're trying to find the distance between A and B, if you look, we could think about this 1, 2, 3, turn it into a right triangle, then 1, 2, 3, 4, 5, 6, 7, 8, 9. That side is a length 9. Okay, so now from here, we have ourselves a right triangle, and we know how to solve a right triangle. Hopefully, we can use Pythagorean theorem. So a squared plus b squared would equal c squared. Okay, now, if we think about it, 9 squared plus 3 squared, I don't care which one's a or b, but those two legs. Okay, that will equal c squared. We hopefully know 9 squared is 81. Oops, that's not a good 8. Plus 3 squared is 9. All of that will equal c squared. 81 plus 9 is 90. We take the square root. Now notice it says round to the nearest tenths place. So it's up to you. You can use the calculator on your computer, on your phone, desmos.com/scientific. That's a great option. So square root of 90. I hit enter, 9.48. So if I round, that's going to be 9.5. Okay, so C has a length of 9.5. Remember, C is the distance from A to B. So that'd be one way, using the Pythagorean theorem. Now the second way, it's very similar to that. It's just called the distance formula, okay? But it essentially is the Pythagorean theorem. It's just we kind of combine it all so it's one step, okay? And I'm guessing you've heard of this before. But if we think about it, if we found the distance of this side length, so side A, that's the same as if we take this x value and subtract this x value. Okay, so we can do x2 minus x1. Then we have to square that because that's a squared. Okay, so just like before we had 9, if I had taken 4 minus negative 5, I would have got that 9. Okay, now we need to add that to b squared, which in our case is the change in y. So y2 minus y1. And if we square that, that would equal c squared. To get rid of c squared, we take the square root. So we'll add that in right now. Take the square root of both of those. That was terrible. I can do better than that. So the square root. And there's our distance formula for any time we have 2 points. So first thing to remember, x comes first, then y. So 1, 3, and 5, 6. We'll set this up. Take the square root of, so I'll do 5 minus 1. We square that, plus, then it's going to be 6 minus 3 squared, okay? So 5 minus 1 is 4. 4 squared is 16. So square root of 16 plus 6 minus 3 is 3. 3 squared is 9. We square root that. It's square root of 25. Now some of you might be thinking, well, square root of 25 could be plus or minus 5, but this is distance, so it has to be a positive distance. We can't go negative with our distance. So 5 is our answer. Okay. The next one, the final one on distance formula, same exact thing. So if you want, pause the video, give it a try right here in our distance formula. If you prefer, you can draw it on the graph and use Pythagorean theorem. It's the same thing. Okay. But square root, we'll do our x first. So negative 5 minus negative 3. Square that, plus, over here then, it's going to be 2 minus negative 6. We'll square that. Now keep in mind, if we subtract a negative, that's like adding it. So negative 5 plus 3 is negative 2. Negative 2 squared will give us 4. Meanwhile, 2 minus negative 6 is like adding that 6. So 8. 8 squared is 64. And 4 plus 64 gives us the square root of 68. Okay, we need to find it. It says to the nearest hundredths place. So we go up here, square root of 68, hit enter. 8.2 would be the tenths, 2.4, but we have to round, so 246 makes us round up 8.25. That is the distance between these 2 points. Okay, now the other thing we're talking about today is how do we find the midpoint between 2 points? So if we have the point 10, -2, and 7, 4, okay, there's a couple ways we can think about this. The first way, you can think of it as you have your 2 points, x1, y1, and your x2, y2. That's supposed to be a 2. You find the distance between those, the total change, and then each of these will be the half change between it. So half of that change. So if you're not sure what I mean by that, that'll tell you what the midpoint is. Okay, these are essentially the same way. It's just two ways of thinking about it. Do you like the graph or just an equation? So right here we have our 10 and our 7 for our x. So let me rewrite this. So 10, -2, and 7, 4, and we want to know what our midpoint is. So the total change from 10 to 7 is -3. So half of that, this will be -1.5. This will be -1.5, which means 10 minus 1.5 leaves us with 8.5 as our x value. Meanwhile, -2 to 4, that is a change of +6. So we know that we are going to have +3 to the midpoint, +3 to the midpoint. So -2 plus 3 would give us a 1. And right there, if you want, you can write it in here, 8.5 and 1. But that is our answer. Now, if that was kind of confusing to you, you can also use the formula. So in order to do this, our midpoint formula is just x1 plus x2 divided by 2. Ooh, that's sloppy. And then y1 plus y2 divided by 2. Okay, those are our two options. So on this next one, in order to do this, we got to first establish what is A and what is B. So A is 1 to the right, 5 up, so 1, 5. B, meanwhile, is 5, -3. Okay, so now we're going to add those. 1 plus 5 divided by 2. So 1 plus 5 is 6, divided by 2 gives us 3. So our midpoint is at 3. Then we're going to do it for y. So this one will be 5 plus -3 divided by 2. 5 plus -3 is 2. 2 divided by 2 is 1, so 3, 1. If you want to check it, go over here to 3, 1. You can graph that, and you can double check then. So it's down 1, 2, 3, 4 over 2. Down 1, 2, 3, 4 over 2. Since it was the same, like rise over run for both, we know we did it right. Okay, the final thing I want us to talk about today, this story problem here. It says in 1993, the average Indianapolis Colts ticket price was $28. And in 2001, the average price was $56. Okay, now we're not 100% sure about this, but assuming it's kind of followed a linear pattern of growth, we want to find that midpoint and estimate what the ticket price was in 1997. Now, the easy thing about this one is 1993, 2001, 1997, they already told us the midpoint in terms of years. So we can know that in 1997, this is what we're going to estimate. Okay. Now, to find that midpoint for the ticket price, we have one other point. So 28 and 56, it's up to you how you think about it. Find the total change, divide by 2, or just add them together, divide by 2. It's going to give you the same idea. 56 plus 28 divided by 2. So if we add that up, 56 and 28, we're going to get 84. Divided by 2 gives us 42 in our context dollars. So in 1997, the average price was $42. All right, so there is a Delta Math assignment. Go ahead, sign in. Let's get that done. If you haven't done the test yet, please reach out to me. If you're at school, we got to get that done. If you haven't been at school, send me an email and we'll figure it out. But hopefully you guys have a great day, and I'll talk to you tomorrow.